Hey guys, good morning. Welcome to the Aerospace Structures lecture series. Today we are going to see the continue of the last class about the fatigue strength and its analysis. So in last class we have seen about the fatigue fracture. Now we will see the second topic of this fatigue loading. So in introduction of the fatigue loading, fatigue is a progressively applied load on the structure. It produces structural damage that occur under the cyclic loading. Most commonly it happens in the aircrafts, bridges, rotating machineries such as wind turbines, gas turbines, steam turbines, and it leads to crack initiation and the propagation, which eventually causes the failure of the material. Fatigue loads, unlike the other failures, fatigue fractures fail structural systems with the damage accumulation as a result of repeating loading and unloading. This cycle loading is called fatigue loading. Types of fatigue loadings. One is due to the constant amplitude loading, where the repeated load cycles with the same magnitude. Second one, variable amplitude loading. The load fluctuates in magnitude. Third one, fully reversed loading, alternating between tension and compression. Cyclic loads take place. Non-zero mean loading, cyclic loading with a mean stress component. Coming to the fatigue load form, arbitrary fatigue loading. Fatigue load fluctuates randomly in the terms of cycles, amplitude, and frequency, so called random loading. Random loading is defined as irregularly fluctuating loading, namely irregular loading. You can see the graph between loading versus time. This arbitrary fatigue loading has its own amplitude and frequency with different cycles. This actual loading pattern called it as random loading or irregular loading. Next, coming to the constant amplitude loading. The random loading is complex and difficult to handle, so constant amplitude loading is usually used to evaluate the basic fatigue phenomena. Constant loading is a loading which a constant amplitude and this period from minimum or the maximum to next minimum to next maximum of the waveform. The amplitude and means are usually used as representatively mechanical quantities of fatigue loads. In this graph, it is a graph of loads and the time. This amplitude of maximum minima will be repeats in upcoming or consecutive cycles. Fatigue loads forms load ratio or stress ratio, we call it as R, that is a minimum load by maximum load, that is sigma minimum by sigma maximum. Amplitude ratio A will be the loaded amplitude by average load in the cyclic patterns or cyclic loads. So that is sigma A by sigma M. The various constant amplitude loadings are given this pattern from the mean value, may be a tension or fluctuating load, zero compression, that is a pulsating load or compression, or tension is zero, whereas ratio will become zero, and tension compression can be or maybe 1. These are the various constant amplitude loading patterns. Next, coming to the fatigue load form under this variable load, the amplitude is not constant. It is also called irregular loading or spectrum loading. Here, peak, valley, positive range and negative range can be occur. It will be maybe a reversal in the uh, pattern of loading. Reference loading, average loads above all the load history. We can see the graph between loads and time where the range and peak value, valley value, reversible loads and irreversible loads, reference load from the mean axis. The stages of the fatigue fractures already we discussed in the last class, that is the crack initiation, crack propagation and final fracture. In a crack initiation stage is 1, Crack propagation is the second stage, is a linear stage. In final stage, the fracture get fatigue get cross failure. This final stage sudden failure occurs when the remaining cross section cannot bearing the existing load. Let us take this example of the failure material. The crack initiation like say micro crack from form of stress concentric point. Crack propagation where the crack goes with each cycle often visible in the spectrography. The final fracture sudden failure when the remaining cross section can't bear the loads. Let us have few applications or the few example of fatigue loading considered in the aerospace application. Aircraft wings and fuselage subjected to repeated pressures and aerodynamic load, which leads to the fatigue loads or fatigue failure. In a landing gear, repeatedly high impact load during takeoff and landing with high temperature or the sudden impact leads the landing gear fatigue failure. Next, coming to the turbine blade fatigue cases, high cycle fatigue due to aerodynamic forces, low cycle fatigue due to the centrifugal and high temperature, in high speed operation. Let us take some testing methods used to find out or used to analyze the fatigue strength of the material. One is rotating beam test. It is a common for all metals where you can test the sample HTML testing sample. You can place in the rotating beam test and you can get the all testing data of fatigue loads. Second one, axial loading testing used in the aircraft material to understand the fatigue property of the aerospace material. Coming to the third one is this crack growth rate of measurement, that is a dA by dN versus the delta K, which helps to predict the life of the component. Next, how we can prevent the fatigue in different stages. We can optimize the design where we can avoid the sharp corners and the stress concentration. Second one, we can avoid this prevent the fatigue by selection of good materials where use alloys with high fatigue resistance. Also, we can do the surface treatment to short peening or coating and cause hardening, which regular inspection maintenance also ensures that fatigue prevention by using of NDT testing like ultrasonic and X-ray inspection. Let us go with a small the case study of this example. The example of Airlines Flight 243 in 1988 cracks the failure due to the fatigue load happening in the aircraft structural. Fatigue cracks in the fuselage leads to structural failure. The, the moral or lesson where can understand this fatigue, importance of the production inspection and the metal selection in the fatigue prone area need to be concentrated. So thank you. We'll see this case study in elaborately in the upcoming classes. The live examples of the fatigue in aircraft in the next class. Thank you.